For those of you who were in the second Med Micro lab starting at 2:30, we didn't have an opportunity to go through all of these practice questions together, and so this video is going to walk us through how to solve them, some tips, some tricks, maybe some shortcuts, ways to help you think through when approaching problems such as these. So for number 4, the question states, you are now handed a tube that has a concentration of 2 times 10 to the 9th CFU per ml. There is 200 microliters of culture in your tube. And the question is asking, how many cells can you expect to find in that culture tube? Well, I've already have it written here where we have our total cells equals the concentration multiplied times the volume. And like always, I like to identify my variables. And these ones are pretty straightforward, fortunately. So first thing, the concentration is given to us in the problem. It is 2 times 10 to the 9th CFU per ml. So I'm going to go ahead and write this off to the side here. And then the next variable is the volume. And we're told that we have 200 microliters. Now, we've emphasized in class that microliters and milliliters don't play nicely together. So we want to convert this 200 microliters into milliliters. That conversion is for every 1 milliliter, there are 1,000 microliters. So that would mean that our volume is 0.2 milliliters. So now one other thing we can do to help us with our arithmetic is to convert all of these numbers in the same format, meaning scientific notation. I find that that's personally easier for me, and hopefully you'll see it'll be easier for you as well. To write 0.2 in scientific notation, we have to move our decimal point once to the right, which means that we are now left with 2 times a factor of 10. Because we moved the decimal point 1 to the right, that actually means that we're ending up with a -1 in our exponent. And I'm going to take down my units. These are, again, in milliliters. So now we have 2 numbers that look pretty similar, and we can multiply them together a lot more easily. If I rewrite the equation over here, plugging in my variables, we have 2 times 10 to the 9th. I'm just going to write cells per ml. Remember, those are interchangeable. This is going to be multiplied now, times 2 times 10 to the -1, and the units here are milliliters. And so now, our trick for multiplying scientific notation is we can take these first 2 numbers and multiply them like normal. 2 times 2 gives us 4. And we're always going to bring down our times 10 because our answer is also going to be in scientific notation. And so now we're left with figuring out what to do with our exponents. Well, when we are multiplying 2 numbers in scientific notation, we can combine or add the exponents together. So what that means is that we do 9 plus a -1, or another way to think of that is 9 minus 1, which gives us an 8. We can cancel out some units here. So we had a milliliters in the bottom and we had a milliliters in the top. So that leaves us with cells. And we look back at the question to make sure we did everything correctly. It asks, how many cells can you expect to find in your culture tube? And sure enough, we have our answer with the proper units in cells. Answer being 4 times 10 to the 8th. Now, let's move on to the next question. It states, our lab instructor needs you to dilute the culture so that the new concentration is 4 times 10 to the 8th CFUs per ml. So this is a little bit confusing because now we're taking 4 times 10 to the 8th cells, and we want a concentration of 4 times 10 to the 8th CFUs per ml. But actually, this is going to be a little bit simpler than we probably are thinking. Now, we can use two different equations here to solve this, and so we'll stick with the equations that we were given. This CIVI equals CFVF, and then we have another equation here, is this volume final, or VF, equals the VI plus the amount of broth that we've added to a tube or a culture. And so let's go ahead and plug in some of these variables off to the left-hand side. The problem states that our new concentration is 4 times 10 to the 8th. So new we can think of as final, so that would mean that our CF is equal to 4 times 10 to the 8th CFU per ml. And we're just taking the same culture from the previous question. So our initial starting concentration for our tube is going to be 2 times 10 to the 9th CFU per ml. Now we can approach some volumes. We are told that we take the culture from the previous problem, and actually we're given our initial volume as well. It's up here, this 200 microliters. And again, we can write this in scientific notation, and instead of walking through this again, I'm going to go ahead and just take this value right here that we've already figured out. So 2 times 10 to the negative 1. And again, bring down my units, we have some milliliters. So now we know we have to solve for our volume final in order for us to figure out how much broth it is that we need to add to dilute out our culture. So to start off, we're going to do our C1V1 equation, and I'm going to fill in the variables, writing them out. 2 times 10 to the 9th CFU per ml. That will be multiplied by 2 times 10 to the negative first. It's in mLs. Set that equal to our final concentration, which we know is going to be 4 times 10 to the 8th CFU per ml. Multiplying that times our final volume, which we will have to solve for. So when we are looking at a question like this, and we are trying to find a single variable, we have to make sure that the variable is isolated on one side of the equation. So the easiest thing for us to do is to try to cancel out this 4 times 10 to the 8th CFU per ml that's sitting next to our VF. In order to do that, I'm going to divide this side of the equation by that same number. And ultimately, this will cancel out and leave us with VF on this side. But anything that we do to one side of the equation, we're going to have to do to both sides. So over on this side, I'm going to do the same thing to keep everything even. So now we can cancel out our 4 times 10 to the 8th CFU on the right-hand side, and this leaves us with 2 times 10 to the 9th times 2 times 10 to the negative first divided by 4 times 10 to the 8th. This is all equal to our VF. And even though this might look a little bit daunting, I promise you it's a lot more straightforward than we think. So first, I'm going to ignore that 4 times 10 to the 8th at the bottom, and I'm just going to be focusing on the top. And we're going to try to simplify this in combining like terms. So in order to do this, I'm going to do the same thing like I did previously, where I'm going to take the first two numbers that are out front, I'm going to go ahead and multiply those together. So that will leave us with a 4, Like always, I'm going to bring down that 10. And actually, same thing as before, what we will find is we have to do 9, then plus a -1. So another way of thinking about that is subtracting 1 from 9, so that gives us with an 8. And the units up here are going to be CFU per ml times ml. And now what we can do is divide all of that by 4 times 10 to the 8th CFU per ml. And what you probably noticed is that now the top is actually equal to the bottom. So we can cancel these out. And we can actually imagine that there's an imaginary 1 in front of this ml. And so what this means is that our final volume is equal to 1 ml. This was a multiplication symbol. But that's actually not our answer. We're close, but not quite. We can add our 1 ml over here if we want. But the question is asking us, how much broth would we need to add to the tube in order to make the new concentration? It's not asking us what the final volume is. So if we now take this second equation that's up at the top, we can plug in our values and figure out how much broth needs to be added. And we already have all of the answers that we need over to the left-hand side. For simplicity's sake, I'm going to actually just keep these in whole numbers. So we'll start out the VF being 1 milliliter. And we're going to write this as 0.2 milliliters, which is the same as that 2 times 10 to the -1st. And all of that would be adding that together with the broth, these two sides will now be equal. So now it's just as simple as doing some subtraction. If we find the difference, we have 0.8 mLs of broth, and that is going to be our answer for this question. All right, so last question, number 6. We're starting out with some new tubes, and now we're handed a tube that has a bacterial culture in it, and it has a concentration of 5 times 10 to the 6th shown here. And we're told that we diluted it out with some broth, and now our tube is going to be at a concentration of 1 times 10 to the 6th cells per ml. And the question is first asking us, what is the dilution factor? Well, the equation we can use here, because we are given 2 concentrations, are the dilution factor being equal to CF divided by C initial. So if I just plug my numbers in over to the side, first and foremost, we know that we're ending up with a culture that is 1 times 10 to the 6th cells per ml. We are starting with a culture that is 5 times 10 to the 6th cells per ml. And we can just plug those numbers now right into our equation. And I'm going to write them on top of one another rather than side by side like the equation looks above, because that makes it easier for my brain to figure out what we can cancel out. So if I write this all out, this one is actually not so bad because a lot of this will end up canceling out. We notice that, first of all, the units can cancel out. And actually, this times 10 to the 6th can also cancel out because it's present on both the top and bottom. So what this leaves us with is 1/5. And so that means that in order to go from our initial culture tube to our final culture tube, we performed a 1:5 dilution, or a 1/5 dilution. So that's actually our answer. We don't need to simplify that or write it in terms of decimal points, because we'll find that this is actually easier for us to work with, especially when we are dealing with serial dilutions, which we'll talk about next week. So now the question continues on. It says, if we used 100 microliters of that initial culture, how much broth did we add to the tube to get the final concentration? So we have to add a number of different equations here, and I will actually add one more equation, which is that same one we used last time, that VF equals VI plus broth. So now we can look at our VI and VF and figure out what we're solving for. And ultimately, what we'll need to solve for first is our final volume. That's not quite what the question is asking, but we are given the initial volume, which is going to be 100 microliters. But remember, microliters and milliliters aren't compatible, so we'll need to change this over to our 0.1 milliliters. And like I've mentioned before, I like to even take it a step farther, and I like to write this number in scientific notation. So this will be 1 times 10 to the negative first. And again, keeping our units, that'll be in milliliters. So now, plug in our numbers. We end up with 5 times 10 to the 6 cells per ml. This is going to be multiplied by 1 times 10 to the negative first mLs. That is going to be equal to 1 times 10 to the 6th I'm running out of space a little bit, but I'll try to squeeze it in, and our final variable is going to be our final volume. Okay, so the same thing like we did above, we want to isolate our variable, and so what we'll do is divide both sides by this 1 times 10 to the 6th. Now again, we can cancel out some numbers. So this whole thing on this side will cancel out, top and bottom. And now we can actually cancel out some other things over here. So if we wanted to, we could cancel out our 10 to the 6th. We see that here. And we can actually cancel out our cells per ml over here. And believe it or not, we can actually also cancel out these 1s that are over here. So what this leaves us with is 5 times 10 to the negative 1. And that is going to be equal to our final volume. If we do 5 times 10 to the negative 1, that is going to give us 0.5. And don't forget our units we left behind. We got to bring down this milliliters. So now we know that our final volume is 0.5 milliliters. And that's still not what the question is asking. We did find our final volume, which is great, but we need to figure out how much broth was added to the initial culture to get to this final volume. In order to do that, we can use this equation up here, and we know our initial volume was 0.1. We know that our VF is 0.5, and so if I just kind of continue on this equation over here, what I will do is I will subtract this 0.1 from both sides. And you'll see here, again, the math really isn't that hard once we really get down to it. This leaves us with our answer that the broth volume, the amount of broth we needed to add to our tube, is 0.4 milliliters. Now, if we were to write this, we could also say this was 400 microliters. That would kind of match the wording of the problem that initially gave us with that 100 microliters. But either one of these answers would be correct.